Good morning. Today we are starting our very last unit of math, unit 11. It is a short unit. We are going to do all 4 objectives this week. So we will be testing next week. And then our last week of school will be for retakes, if we have to do any retakes. Yeah, we are that close to the end of the year, my friends. Anthony, 12 actually, I need to change it.
So like what day?
What day what?
You're not on Thursday, right? No, like what day? It's like the last day of school.
June 9th.
So we are not Thursday.
It's a Thursday.
So
Next week we have Memorial. Guys, listen please. Listen please. Next week, Monday, we do not have school on Monday because it is Memorial Day. So we will have a review day on Tuesday, practice test Wednesday, real test Thursday. I doubt I will have it all corrected and ready for retakes on that Friday. So it'll be any retakes that people still need to do for other tests that we have and Khan Academy. The week after that will be Monday, Tuesday will be retakes. Wednesday, we're going to be wrapping up for the end of the year. Thursday, the 9th is the last day of school. So we have this week, next week, and the week after. Okay, so it is wrapping up really quick. So this week, next week, and the week after is our last week of school. This is our last full week of school. This is the last week that we have 5 days of school.
So yeah, cause the next Thursday.
No, the next.
Oh my God.
Yes, not this Thursday,
Yeah.
not next Thursday, but the next Thursday.
Yeah.
You are correct.
Oh.
I followed you. I got you. All right, so because we have a lot to get through this week so we can do our test next week, we need to focus. So today we are starting with objective CO69. I can calculate the probability of a single event. So we started with Khan Academy on Friday, had to do with probability. So when I said watch the videos, I really need you watching those videos. Some of us didn't watch the videos last time. You need to watch the videos that are assigned. If you don't watch the videos, it's going to hurt your grade. It's a part of the grade to watch the videos. So probability, we're starting off with just the simple, a single event. Okay, so let's look at our terms that we need to know to make probability a little easier. Aiden, attention should be up here, not turned and talking. Okay, attention up here. Outcomes, the possible results when experiment is performed. An event is a collection of outcomes of an experiment. So an example would be an event that involves tossing a coin is getting heads. So the event would be getting heads, the event would be getting tails. When you toss that coin, your event is that outcome. Favorable outcomes are outcomes corresponding to a specified event. So if we're talking about when you flip your coin and you get heads, every time you flip the coin, the favorable outcome would be when it lands on heads. Probability is a number from 0 to 1 that measures the likelihood that the event will occur. If I flip a coin, what is the probability that it will be heads? Theoretical probability is a probability based on all of the equally likely outcomes of an experiment. The theoretical probability of an event is given by P, the event. The probability is the number of favorable outcomes over the total number of outcomes. So when we say it's over, what math do we do when we have that fraction bar? Anthony? Divide. So we take the number of favorable outcomes, how many times it's going to land on heads, and divide it by the total number of outcomes. How many outcomes would there be?
2.
Yeah, 2. You could get heads, you could get tails. So the total number of favorable outcomes would be 1, and the over 2. So it would be a half. So the probability is a half. If we do the division, we get 0.5, which is 50%. So theoretical probability is 50% of the time when you flip a coin, it's going to land on heads. That's theoretical. This is how it should happen. Does everything happen how it should happen?
No.
So we have experimental probability because it doesn't always happen the way it should. You could flip a coin 5 times and get heads every single time. Ooh, that doesn't follow the theoretical probability saying this is what should happen. It's saying this is what actually does happen. Okay, because every experiment, it doesn't always follow the way it's supposed to. So the experimental probability is a probability based on repeated trials of an experiment. The experimental probability of an event is given by the event equals the number of successes over the number of trials. So let's say I flipped to that coin 5 times, so my number of trials is 5, and it landed on heads 3 out of the 5 times. So who has their calculator out? What would be my decimal? Josie. 0.6. So what's my percentage? 60%. So, is my experimental probability always going to be the same as the theoretical? No. Well, we're not being silly. So, experimental is what actually happens. Theoretical is what should happen. Okay? So, it looks like we're doing the same thing for our formula. Number of favorable outcomes, number of successes over the total number of trials. Kind of looks like it's similar, but they're not going to be the same. Sometimes you might get that theoretical probability might come true with your experimental probability. Oh, I'm supposed to get heads and then I'm supposed to get tails. That's what actually happened. Sometimes it'll work out that way. Not always. So let's practice finding some probabilities. So find the probability of randomly choosing an X from the letters shown. So what is going to be my first number? So look at our letters. We have X, R, R, S, X, H, H, Z, X, S. If I reach my hand into a bag and pull out a letter, how many chances do I have of pulling out an X? Zoe? Where did you get 3 from?
Because there's 3.
There are 3 X's. So my theoretical probability says it could happen 3 times. I have 3 chances of pulling out an X. Out of how many, Landon? Where did you get 10 from? Yeah, there are 10 letters that I could pull out. So I have 3 out of 10 chance to get an X. What is my decimal? Josie.
0.3.
So what is my percentage? So if I divide 3 divided by 10, I get 0.3. 0.3, I know that's 3/10. 3/10 is 30%.
So all you're doing is you're doing the fraction, then you divide it down to the decimal, then you put it into the percentage.
Yes. So what Landon said was we're finding our fraction, dividing it down to our decimal, and then turning it into a percentage. So the probability of choosing an X is 30%. Yes.
What if you have a number that's going to be bigger than 100%? How do you do that?
Can you have a number that would be bigger than 100%? So if we have our total number of trials is at the bottom and our number of successes are at the top, we can't have more successes than we have trials. So it'll always be between 0 and 1. So when we look at the probability definition, it's always going to be a number from 0 to 1. It'll always fall in that range. Oh, it's a good question. But that's why it could never be more than 1. Because your total number of trials would change.
You can never change it to 0 to 1. You can't change it.
Well, you can't have more outcomes than the outcomes that were performed. So number of favorable outcomes over total number of outcomes, you can't have more favorable outcomes than how many you've done. You could have 10 over 10, which would equal 1, which would equal 100%. Yeah, so you could get it to be 100% if you have all favorable outcomes. But it will never be bigger than 100%. Anthony.
Is there like SEO that we had to make it to mixed number?
What?
We have done mixed numbers, yes. We are not doing mixed numbers with this objective. Okay?
Is it because the fractions are like too bro?
Because our numerator is always going to be smaller than our denominator.
Okay.
Either equal to or smaller. So we won't have any mixed numbers. Let's look at our second one. So that's finding the probability. That's the theoretical probability. Now let's look at finding an experimental probability. So let me scroll up a little bit. Probabilities can range from 0 to 1. The closer the probability of an event is to 1, the more likely it is the event will occur. So if our probability is 0, it's impossible. It's not going to happen. If the probability is 0.25, it's unlikely because it's under a half. If it's halfway, it's likely to occur half the time. If it's at 70.75, then it's likely it'll occur. So the closer we get to 1 is 100% certain it will occur. So the closer you get to 1, the bigger a chance there is of it happening. Landon.
What if it's like in the middle?
Then it's 50-50. You're at 50%.
I'm saying like in the middle of
So if it's bigger than 0.5, you're closer to 1 than you are to 0. So it's more likely to happen if you're over halfway. It's less likely to happen if you're under halfway. All right, so let's look at our example. A cat knows the shake. Oh, a cat, not a dog. A cat knows the shake command offers one of its front paws to shake. The table shows the number of times the cat offered each of its paws when asked to shake. So you held your hand out to the cat and you said shake. And sometimes the cat put out its right paw. Sometimes the cat put out its left paw. So it put out its left paw 38 times. It put out its right paw 12 times. Apparently, this cat can do that. So here is our question. Here is the question. What is the experimental probability that the cat will offer its right paw when asked to shake? So our first step, determine the number of successes and the number of trials. So what's our top number going to be? What are the successes of the cat offering its right paw, Brielle? 12. What is our bottom number going to be? Tristan?
50.
Why 50, Tristan?
Because if you have 36 and 12, well, no, 38 and 12, you add them up, and And 8 and 2 is 10.
So
and 3 and 1 is 4. Plus
Our-
another one.
our
is-
bottom number, yep, the bottom number is the total number of trials. So we had 38 left pause, 12 right pause. We have to add them together and we get 50. So then find the probability. What do we have to do? Josie, what is 12 divided by 50? Peyton?
0.24.
So what is our percentage? 24%. So is it going to be likely or unlikely that the cat is going to reach out with its right paw?
Unlikely.
It's going to be unlikely. Okay. But our percentage is 24%. Does that make sense? So today, that's all we're doing is we are finding the probability of different events. So,
Explain that it was like on Khan Academy now when it's explained.
Yep.
So in the homework, all we're doing is find
so let's look at our homework page 169. Page 169, 170. So on the front, you're gonna have to figure out the trials, the successes out of how many altogether. So how many? 169. We are going to do the front and the back. All of them. Okay, we need to be able to answer from those word problems. For my friends at home, we hope you are well and we hope to see you soon.